What's the sound? The bird?
Sorry.
Oh, from Grander. From Grander.
Yes.
How come got the bird chirping? Is it ready? Your bird?
Not my bird, but the bird outside my house.
Wow, so good, it's quite constant.
Yeah, just stop. Okay, started again.
Wow, very good. Where's your place? Near the reserve, Close reserve, Bukit Timah Reserve area.
No.
Okay, you're the school all doing statistics already, right? Is it starting all the P and C? Grander
Yeah.
also, pricing probability already, right? Tested already, right?
We are at
Sorry, I'm the last.
Yes, you're last.
But it's early.
Oh, okay. Can't hear. Only the bird is louder. Okay, so Kai-Xing,
Sorry.
no, it's okay. So Kai-Xing, you are at the next discrete random variable,
No, we're at the one after
Huh?
that. Normal distribution.
Normal distribution. Your school a bit fast, Yingxi, your NJ where?
Probability.
Huh?
Probability.
Okay. Bernice?
DRV, discrete random variable.
Oh, Grander?
Binomial distribution.
Oh, okay. So y'all are very good in all these things already, right? Yeah, you.
Wait. No. I'm at discrete random variable.
Okay. We will probably hurry a bit on this sort of thing. Okay. Last time we stopped at this sort of the mixed method, the killing the brain question, this thing. Yeah. Okay. So how is it? Y'all can actually find out the answer, and if you're really interested, you can let me check the answer. Yeah, whether you got it or not.
Oh.
Yeah. Okay. Yeah. For example.
Okay.
Then this one we quickly go through. Some of the P and C will involve dividing into subgroups. Okay, so since you all have been doing permutation and combination, right? Okay, so let's look at this question. This one is on dividing a group of objects into subgroups of objects. So let's say we want to do it this way. Divide. Divide a group of 12 into sizes 3, 4, and 5. So what is the form expression for it? Yeah, what is this expression? So what is the expression? Yes. Okay, let's do it. Yeah. Bernice, what is the expression?
I don't know. Can I just anyhow? Is it 12? 12, choose 3. And then 9, choose 4. And then 5, choose 5. Is it?
Is it? Mingxi, is it? Huh? Yes. Okay, is it very loud? A bit loud. Okay. Sorry. Okay, next one. Very good. It's correct. I think it's correct. Correct. Okay, next one. How about splitting a group of 12 into 3 groups of equal sizes to participate in the 3 different learning journeys? Okay, this one we see whether no. Okay, never mind. Grander. What is the answer? Grander, the slotting machine chose you. Yeah.
12 choose 4. Then 8 choose 4, 4 choose 4.
Okay, very good. Kai-Xing, is it correct? Yes or no?
I think it is.
It is, Okay, good. Correct. Well done. Let's go. Okay. There are some instances Okay, for a moment, I also want to say that going forward, right, all the notes will be condensed. I don't want to print, have all these open spaces. Okay, so it'll be no spaces between. Then you have to use your own writing paper and write your answer and so on. Okay, can Okay, here you have a group. You can split it into subgroups, but some subgroups have the same properties. Because of that, you need to have some cancelling the effect, okay, of the choosing from there. So there is the repeating group effect. Okay, so for example here, how many ways to divide 11 people into sizes of 4, 4, and 3? Okay, let's start with Mingxi. Sorry. Okay, no more already, no more already. Sorry. Okay. Mingxi, how to divide?
11 choose 4. Then 7 choose 4.
Okay.
And then 3 choose 3.
Doesn't matter, 3 choose 3, okay.
They are by 2 factorial.
Okay, well done. Okay, can. Because you are just doing a group of 4 and 4 equal sizes, so they are of the same properties. Can? Okay. Yeah. This one, part B. How many ways to divide a group of 12 into 3 groups of equal sizes? So this one, Kai Xing. Kai Xing, your one a bit soft, yeah. Divide by 3 factorial. Can? Okay, good. Yeah, so we cover this part of things. Yes.
Mr.
Question.
Lau. Oh yeah.
You go first.
Oh, how you differentiate between like just now
This one.
part B and this one part B?
Very good. You are very alert. Okay, actually, the difference is because they are on the different journeys.
Oh.
Yeah, so when they are in the different journeys, learning journeys, then the differentiating will come in.
Then for part A is because all the groups are of different sizes, correct?
Yeah, that's why there's no equal properties involved. Okay, they are all different.
Okay.
Thank
you.
Bernice, same
Same question, yeah.
Oh, very good. You're very alert. Okay. Yeah. Now you learn circular permutation, right? Okay. You also learn circular arrangement. So there are actually different arrangements. So it's like arranging in a circle. Then whether with seats numbered or not numbered, that type of thing. Okay, so you remember these sort of questions. Then of course the last one is if you have other settings. Okay, instead of circle you have other things. Yeah. So we look at this basic formula. So when you write your circular permutation, you must write n-1 factorial. Try to, okay? So that to tell people you are doing a circular permutation. Then here, if you have I think identical objects, then you are using the circular permutation. Circular permutation plus the idea of repetition in the earlier part. So this is your formula. Okay. Then if you permutate grouping, okay, you have some objects grouped together, then your permutation must be done in such that you do a circular permutation followed by the internal permutation of within the group. Okay, so internal, external. Okay, yeah. So next one, then if you are doing permutation in a circle with some of these objects are separated, then you need to do the slotting method plus the basic formula for the circular permutation. Okay, so we do the you get the idea, this sort of thing. So we move a bit. Okay, now come this example. Okay, so this one everyone thinks about it, then we will pick someone to do it. Okay. sorry, I covered it. Okay.
Number one.
Huh? What? Number 1? 6. Okay, how to count 6? Mingxi, Kaixing, Grander, Bernice, then Grander, Kaixing. Okay. Kaixing?
No, Mr. Lau.
What?
Why?
1, 2, 3, 4. What? In your screen, right? On your screen, you see Mingxi is the first, Bernice is the last to come in. So 1, 2, 3, 4, 5, 6 lah. Go backward. So Kaixing. If not, I turn again. Same. It's a fate.
You turn again.
2 also, you see? 6 or 2 also you. So no choice. Okay, 11 people are seated in a circular wedding table where every seat is identical. So 3 are the same family consisting of 2 parents and 1 child. And how many ways for the child to insist sitting between the parents?
Yeah, I don't know how to do.
Okay, pass to Grander then.
Is it 11 minus 3 minus 1, then the whole thing factorial?
No, almost. Very good, almost.
Then within the same family, right? It's only like one arrangement, correct?
No. Also no.
But the child, then it's 2 arrangements.
Correct.
So it's plus 2.
Times. It's a process. It's all linked together. Okay. So actually it's 8 plus 1.
Times 2.
But it's actually 8 plus 1, not 8 factorial.
Wait, why 8 plus 1?
The 8 people plus the 1 family, you are trying to put them into together.
Oh, right. But I thought you had to minus 1 afterwards.
Yeah, we minus 1 again.
Mm.
What I mean is we write it in the circular permutation formula way. Can? So we have 8 plus 1 minus 1 factorial. Then what is that?
Okay. Then times 2.
Yeah, then that's it.
Why 2 factorial?
Same lah. 2 or 2 factorial is the same. 2 factorial is because you arrange the 2 parents. So it's just A or permutation. Okay, Kaixing can? Can Mingxi, okay. Next one. How many ways to sit 10 people at the round table with 11 identical seats? So first question here. So Bernice? First question.
Is it 11? Wait, I got this. 10 people around table. Is it 11 minus 1 factorial?
Yeah, you're right. You are using the dummy method.
The empty seat.
Yeah. Okay, or the ghost method. Okay. Yeah, so this is correct.
Okay.
Then next one, Mingxi, how about if we are given 12 identical seats, but only 10 people? So how to arrange these 10 people among the seats?
11 factorial divided by 2.
Almost, but right in this way. Can? Try to write in the circular permutation type of format so that people know you are doing circular permutation. Then Kaixing, you understand this? Because the 2 empty seats with only 10 people, the 2 empty seats are going to be registered the same way, same thing. Okay, we are going to assume them the same object. Okay, so there'll be a 2 factorial for the repetition of the 2 identical objects. Okay, or you can say two identical dummies. Yeah, get it? So any question on this? Very good, very good. Yeah, how about this? Permutate a group of n distinct objects with distinct seeds. Okay, so this is your n minus 1 factorial for your basic formula, and then times n. You get this idea because of the rotational symmetry. So you have n seeds, you times n, so that you will get all the arrangements taken care of. Okay, accounted for. Can okay, probably it's your revision. So how to sit 10 people at a round table with distinct seats. So it's a direct application. So it's 10 minus 1 factorial times 10. Okay, yeah. How about how many ways to sit 10 people at a round table with 8 identical white seats and 2 red seats? This one, who wants to answer? Someone answer lah. Come, let's roll the thing. Where's the okay? Let's roll. Mingxi, let's roll a bit. See whether is it fair or not. Bernice, Grander. Wow, quite fair. Everyone got one chance. No, Bernice got more. Okay. Yes, Mingxi. Wow. Pricing fewest chances. Okay. Difficult question.
10 minus 1 factorial times 2.
Times 2. Okay. Good. How about Kai-Xing? Do you get the same answer? Then you have to ask your friend, what is it times 2? Then how about you? Don't need to times 2? Huh? You don't want?
Wait, is it 10 minus 1 factorial times 2 plus 10 minus 1 factorial times 8?
Times 2? Like this?
The other one is not times 8.
Times what? Times 8?
Times 8, yeah.
Okay. Okay, must be someone getting it. Brenda?
Is it? As in, I really don't know, but
It's okay.
Is it the 10 minus 1 factorial times 10? Then you divided by 8 factorial divided by 2 factorial.
Oh. Wow, looks good.
I don't think it is though.
Oh, why?
I don't know, never seen it before.
Oh, okay. Then because of that, Bernice?
Well, I don't know, but
Can try? Maybe you get it.
I feel like it's Glenda's answer.
Yeah, actually I think it's Glenda's method.
Glenda's answer.
I think it's Glenda's answer. Yeah, it looks quite legit.
Oh.
That makes sense.
Oh.
Yeah. I think. I mean, I don't know.
Yeah.
Before that, I didn't think of anything.
Okay. What's the answer if you calculate?
Glenda's answer is 45.
45. Wow. Okay.
Yeah.
Will it be so small, the answer? Okay, let's see. If all the seeds are distinct, All the seeds are distinct. What is the answer?
Be,
Then
it'll
Change
be
answer.
28800. If we're all distinct.
All
It's the
distinct.
first, it's like 5.
Right. Then
Mm.
all are identical.
Whole thing over 10 factorial.
Like that. Is it?
Oh,
I mean,
maybe.
huh? Oh, what I'm trying to say is that, do you see that this guy is actually in between them? All the seeds are identical, and all the seeds are distinct. And this guy is somewhere between these two extreme categories, the seeds.
Oh, is it you just remove the 8 factorial?
Yeah, I mean, do you see the sense of all these things? When you do question like that, you also need to feel a bit like how big the number, yeah, from the extreme cases that you got it, because these two are extreme cases. Then the answer for this one must be between them, because they have some identical seeds, some are different, that type of thing. Okay, yeah. So divide away the 8 factorial. Actually, this question is difficult, no? Because this question
You remove the 8 factorial.
Oh, like that. Why? What's the reason?
Because like it's 8 identical
I can't
and
remember.
2 like, as in, no, you
Understand.
remove the 8 factorial at the bottom.
Okay.
But you still multiply by you still multiply by 10 on top.
Like that.
Is it? Yeah.
Okay. No also.
Oh.
I just draw the pattern, then you see. Actually, this question is ambiguous, because we don't know how the white seeds are arranged with the red seeds. So there are two ways to do it. One is this. These are the red seeds. Then the rest are white seeds. Okay, let's say this arrangement versus this arrangement. They are different. Okay, they are different. When you have repeated seeds or identical seeds, you have to really depend on how they arrange themselves. If they arrange themselves in a symmetrical manner, then the answer is different from the non-symmetrical manner. Okay, let's talk about the non-symmetrical manner first. Let's talk about this case. Case 2. Okay, case 2 first. Yeah, case 2. How to arrange them in this case? Then the answer will be this. You see, this will be 10 minus 1 factorial times 10. The reason is this. As long as something is not symmetrical, then this round table will not have its symmetry. The symmetry will be destroyed. Okay.
Oh, so there's no rotational symmetry.
Yeah, because no matter where you sit the person, there'll be always a reference point to something else, like the red seats.
So then why you still include the 10 if there's no idea of rotational symmetry?
Oh, you mean the times 10?
Mm.
Oh, because the times 10 is like all the seats are distinct.
Oh.
Another way you can think about it is, or you'll just do a 10 factorial. Why? Because
because it's 9 factorial times 10, which is 10 factorial.
But you also can think about it as because now the symmetry has broken. It's broken. So in this case, the seats are like a straight row.
Mm.
Can get it, Bernice?
Yeah.
Yeah.
Can sure. Okay. Did your teacher introduce you a way to do all this problem? Another way is to first sacrifice one guy. Do you learn about this method? Sacrificing one person. The idea is like this. You can think of getting a person to sit at the round table. So if the person sit at the round table with, let's say, this arrangement, then the person can sit anywhere. In this case, because there's no symmetry, so there'll be altogether 10 ways to sit.
Wait, what do you mean?
The first person to sit among the chairs, there'll be 10 choices for him to choose.
Mm-hmm.
Agree or no?
Agree.
Once the person sit, the rest of the people will be only 9 factorial ways to sit among the empty seats. Yeah, so this is...
What's the difference between just putting 10 factorial?
This one, same.
Yeah,
It's just
why still
it's the same. It's just that this method, right? Sometimes is when we face with a tricky situation, we are just like test water. So we put some people in, and then test out whether anything will happen. That type of thing. Yeah.
So is the logic like the moment that one person sits, then the next person will have like 9 choices left.
Correct. Because
Then so on.
So correct. Because other people, they will actually be able to tell where is the left and right because of the first person. Yeah, something like this.
But this is for case 2 only, or
you can see case 1. Let's say case 1. Case 1 is the seats are arranged in this symmetrical order. It's perfect symmetry because got the 2 raised seats opposite. So of course the answer probably will be different from the case 2. Okay, so in this case, let's say based on your gut feel, what's the number of ways? Or how do you do it? Or I just tell you, you see, it's logical. We can, if the situation is unfamiliar, right? Okay, unfamiliar situation, we'll use this method, sacrificing something. Okay, so we are going to put in some people. So what we are going to do is, I can choose 2. Why not 1? I want to choose 2 because I want the 2 to fill out these 2.
But how you know the 2 that you choose will definitely fill up the red seats?
I force them there.
Okay.
You can tell them, go and sit there, then that's it. Okay? So then choose 2. You choose 2 people, they will sit at those positions. How many ways to sit them?
2 factorial.
No, 1 way only. Because it's perfect symmetry. Whether the person A is here or B is below or top, no difference because between them there are 4 seats apart, left or right. Okay, then after that you sit the rest of the people. The rest of the people, how to sit?
8. Choose 8.
Finish.
Yeah.
Can? Because you only have the 8 people.
Okay. So this is for the symmetrical one, is it?
Yeah, this is for case 2. Case 1. I'm just trying to introduce to you some strategy. For example, this is a common strategy for cases that are not familiar. We are not very familiar. We have not done this sort of thing before, but it's a bit similar to what we have done before, that type of thing. So we are trying to use such a method to test water, to test out. Okay. You can also do the other way around by putting in the 8 people first. It's the same logic. You can say 10 choose 8. Then what to do? 10 choose 8.
8 factorial.
Now it's like there are some symmetry, right? 8 factorial. Okay. Then after that, something else happened. Divide by 2.
Why?
Because when you times 8 factorial, these two are perfect symmetry opposite to each other. So they may be swapped. The swapping may be the same. No, when they swap, they also have the same number, right? So you have to divide by 2 factorial. But then after that, or 2 factorial lah. Then after that, you times 2 factorial. The reason? Because the two remaining people, they now have two distinct ways to sit between them, between the red seats. Why? Because the 8 people already seated, so they already have a distinct position. Okay? So this is the same answer. Is it okay?
Wait, why is there a divide by 2 factorial again?
Because the opposite 4 seats, they can actually be seated in such a way that they are the same. So for example, if I arrange them in A, B, C, D, E, F, G, H, is the same as E, F, G, H, E, F, G, H, wow, hey, what is that now? E, F, G, what is that H? Okay, E, F, G, then A, B, C, D.
Oh, but why? I see it's not this thing. Oh!
Because it's rotational.
Symmetrical. Right, okay.
It's rotational. Okay, the left and right happen to be the same number, therefore there's still got some symmetry involved lah. Okay. Yeah, what I'm saying is that when you do this method, right, use this method, you need to be very cautious because it's a not familiar situation. Then the number of objects you throw in must be minimal. You don't throw so many because the many you throw, you may not see other things around. It will be complication around.
So what is the total number?
This total number, you have to calculate.
No, as in like for the question.
Oh, the question
You have to combine case 1 and case 2, or like
no,
we just
separate.
take one example.
There will be
Huh?
to answer the question, these two cases will be separately answered. That means you got the two different answers.
So like if you don't say both answers, will you be like marked as correct? If you
No.
only say like one,
No, you'll be
or you have to
incomplete.
say both
Yeah,
cases.
correct. But in exam, you won't have this sort of situation because they will always tell you the exact scenario. Yeah, so you won't
then
find ambiguity.
Mr. Lau, for example, right, what if the two seats in case 2, right, they are not like together, but they are like separated by like a number of seats?
Yeah, then you see.
Like you can separate.
Very good very good Then how to do?
I don't know. Is it the same as case 2?
Is it the same? You all think about it. Will it be the same? Like this?
Yes.
Like this, for example? Like this. Okay. Now, if I not sure what to do, then I will do the method of choosing 10 people. 2 of them. Among the 10, 2 of them. I choose the 2
to fill up the...
To fill up. Okay, now is how many ways to fill them up?
2 factorial.
Will it be different?
Yeah.
Because AC here and BC here, are they the same as BC here, AC here? Different, because
they're different.
Because the number of seats are way different. Yeah, so this is yet another type of case.
Okay, thanks. Thanks, Mr. Lau.
Can so the question is here is not is ambiguous. You need to know exactly how the seats are being arranged. Okay? Can if can, we move to the part C. Part C, yeah. How many ways to sit 10 people at a round table with 5 identical white seats and 5 identical red seats arranged in alternate, now it's very precise, alternate color manner. like this. Yeah, so this is quite a common question because that's how in real life people arrange their wedding dinner seats. Sometimes they arrange in this sort of order, alternate colored seats. Yeah, silver and gold, that type of thing, or white. Yeah, so how many ways to arrange the 10 people now?
Is it 10 choose 5? Then 5 factorial.
Any more? Or anything to add? Just 10 choose 5 times 5 factorial? Or okay, what I'm trying to say is yes, there's a formula for circular permutation, but under some conditions, the circular permutation formula may not work all the time. I mean, may not work directly. So you need to be careful when you face this sort of situation. Okay, so here I would say 10 choose 5 is good. 10 choose 5 is to maybe fill up all these seats. Yeah, but not the 5 factorial. So you should have 10 choose 5. 5 minus 1 factorial. The reason is because the seats are alternate, so these five colored seats are still perfect symmetry. So they form like a mini circle. So mini circle means here is a circular permutation among the 5 people. Then you need to times something else. Okay, you need to times 5 factorial. The reason is because the rest of the people must sit at those white seats, right? So you need to fill up the rest. And because the 5 people already seated, then the rest of the 5 people will have no symmetry to talk about. There's no rotational symmetry, so it's 5 factorial.
Then wait, how come there's no rotational symmetry? Aren't they in a mini circle also?
But this mini circle has been broken up by the different people occupying those seats. So
so it's distinct.
Yeah, so they'll become like numbered seats because of the reference to the people seated. Yeah, so they are become like distinct. Is it okay? So it all depends on the scenario. Some of the identical seats may become distinct later on, depending on what you are doing with them. Okay. So yeah.
Then, sorry. Then for the mini circle for the 5 minus 1 factorial, right?
Yeah.
How come you don't multiply by 5 again?
Why multiply by 5 again? This one is just like you think of just the 5 people seated in those positions. So in this case, there'll be a circular permutation, right? So it's 5 minus 1 factorial, and that's it, finish already.
Oh, because like the formula like above, right, it says that it's n minus 1 factorial times n.
Yeah, that one is for distinct position. But
right. So this one is non-distinct because of the rotational symmetry.
Because all the seats are maybe the same color. All the seats are red, for example, then of course they are identical in that sense.
Okay. Thank you.
Thank you. Can so let's try out this part. I don't know whether you have seen this in your questions, in your tutorials or school questions. This sort of question, whereby people are seated in this sort of triangular or some of this rectangular table thing. Have you all seen question like this?
Yeah.
Have? Yeah. So when you sit n people, right, in a polygonal setting, polygonal means a regular polygon. Okay, so it will be n factorial divided by the number of rotational symmetry. This is just a guide. Okay, just a guide. Yeah. For example, first part A. For example, part A. There's this regular triangular table with 3 seats as shown. Then 8 people are offered this seat. Find the number of ways to sit the 8 people. Don't care about the ABC. I just can copy and paste. Okay, from internet. the table. I want to draw a table, but very time consuming. So I just copy a picture. Yeah. So you want to sit 8 people among 8 people. 8, not 9, 8 people. 8 people among them, among the seats. So how to do it? Yeah, then you find that in this case, for part A, okay, if you talk about in terms of this formula, it will be just 9 factorial. Why 9? Because 8 people plus a dummy. We always think of a dummy. If there's only one dummy, then this will be an extra person. Okay, so a 9 factorial plus the dummy 9 factorial divided by the rotational symmetry is 3. And
how you find the rotational symmetry?
Is how many times you rotate to get back to the same position.
So is it like the number of sides?
A bit like that. You really have to rotate like from the central, you start to rotate. So the sides here, here will move to here, then you move to here and move to here, something like that. So you move 3 times back. Can?
Thank you. Yeah.
Okay, but this formula is risky lah. If you just code formula, it will be risky. So another way you can do it is through the sacrificing method. Again, unfamiliar method. This unfamiliar method is good in many situations. Whenever you find something strange, you may want to try it out. Okay, so how do we use this unfamiliar method to the sacrificing method to do it? First is you have to think of it this way. Let's say I 9 choose 1, including the dummy. So 9 choose 1 person. Then I ask myself, how many ways can the first person be seated at around this triangular table? How many ways?
9 factorial.
No, 1 person only. I push 1 person out. Okay, 9 choose 1 person. Then the person is to
Times
occupy
3
1
factorial.
seat. No.
3.
3.
Why?
If the person is seated here, the person is also can be.
Oh, then there's 3 other ways.
It's the same. But then if the person is seated here, it's different from the one on the left. You get me? And then yeah, all these things. So the first person to sit will be either the first seat on the one side of it or the second seat or the third seat. Okay? And they are symmetrical throughout. So there are basically only 3 ways the first person can occupy. Okay? Then after that, what happened to the rest of the people? Then the rest of the people will fill up the seats, right? So it will be 8 factorial. You get it?
Wait, why 8 factorial? Sorry.
Because there are 8 other people.
So like after the first person fills the seat, then the rest of the seats become, I thought they become distinct.
Yeah, when the first person fill out, right, the rest of the seats will become distinct according to the person.
So it's times 8 factorial.
Because of the 8 seats remaining.
Okay. Thank you.
Okay, any question? Wait, any question? Very important.
No question.
Go to B. Ten guests are invited for dinner and they are going to sit at a long table in this manner. So the long table has the configuration 3, 3, 2, 2. So how many ways to sit the guests if the seats are identical?
9 factorial over 4 factorial.
Sure.
No.
What is the rotational symmetry? Yeah, who?
But you rotate four times, then you get back the same thing, what?
No. You actually rotate 2 times to get back the same thing.
Only 2?
Oh, right.
Yeah, only 2. Only 2. You flip, you get back to the same shape.
Cause it's identical, right?
Yeah.
Wait,
The seats are identical.
it's too big brain.
Oh, you are trying to imagine, huh?
Yeah. Wait, okay, hold on, I got this.
The answer is like that now. So there are 10 factorial over 2. How about if you...
Why is it 2?
Huh?
Why is it 2?
Because you see, you rotate this thing, you rotate 2 times 1 and 2, you get back to the same.
Oh,
You get what I
like
mean?
rotate the whole table.
Yeah, you are rotating the table to get the same shape.
Okay.
Whenever you rotate, you must get back the same shape, that type of thing. You get me? So I draw it here. This is the table. So you rotate, first time you start over here, you rotate, you get this part, and you rotate again, you get back the same thing. You get me? You get to here, you rotate this way, this direction. Yeah, can you just rotate maybe clockwise direction. So the left side will become the right side, and then you rotate one more 180, you'll get back to the left side. Okay? Question? Okay, let's look at the inserting or the sacrificing method or inserting method lah. Okay, so how do we go about doing it another way? So I'm going to have the first person. So the first person is going to sit. First person is going to sit. Yeah. So how many ways can the first person sit among the table?
Then choose one.
Sorry?
Is it 10 choose one?
Huh? Right. 10 choose one? No. No. You'll find that the person can be seated here, 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 here. Okay, the person can be seated here or here, or here, or here, or here. Okay. A or B or C or D or E. If you see at F, you'll find that it's repeated. Why? Because the F is the same as A. Can figure out? Is it very difficult?
Then why is it that in the previous question, we started out with 9 choose 1 times 3?
What was the previous one again?
The part A one.
Oh, this one. This one, right? This question. So for part A, we say what do we have? Oh, I think I know why. Okay.
Choose 1.
Remember this one, the answer?
Yeah.
Then the other one is oh, I'm sorry, it should be this answer. No 9 choose 1.
Oh, yeah.
No 9 choose 1. Why no 9 choose 1? Sorry.
Why?
Can I write back the 9 choose 1 again here? Then I cancel it. Sorry, no.
Cause
we are just getting any random person to be placed at the seat. So we are not exactly choosing one person. We are just getting one random person to go in. Okay. Yeah, so coming back to this one, then what should it be? For B. So the first person to go in will have only 5 ways to do it. Is it okay? 5 ways? Because of the symmetry. Symmetry. This side is symmetrical to the other side. So I just write here, this side, okay, is symmetrical to the other side. Yeah, so the way you put the person, you must be very careful. This is a very crucial number. If this number is wrong, of course you'll be done, finished already. Okay, so this person put in, the rest will be following, right? So the rest of the people are 9 of them, like this. Okay, good.
Wait, why times 9 factorial?
Because you are putting one person in, then once the person is put in, there's no more symmetry. All the position will be decided, right? It will be reference to the first person. So it will become 9 factorial. Make sense? If it makes sense, you look at part C. Four married couples are seated at this square table with 2 seats on each side. How many ways to do so to seat the 4 married couples? Oh, there's a condition. Each husband sits directly across from his wife. You find that to sit this arrangement it's not anyhow 4 husbands go in, that type of thing, or 4 wives go in first. You get me? Because you need to find space for them to sit, for the other partner, so that they can sit opposite. So how to do it? Did you all do the exercise given to you? Huh?
I tried.
Oh, Bernice got can get the answers?
No, I don't know. Like just some parts.
Okay, Mingxi got do? Have or not? Sure or not? You all must send me your solution. Take picture.
Oh.
Very messy.
Huh? What?
Very messy.
It's okay.
My solution very messy.
It's okay. Messy is
And
okay.
I don't know a lot of questions.
It's okay. It doesn't matter.
Can I go to
Can. What?
Can I go to the toilet?
Sure, it's your house. You can go. It's your house. No need to ask me.
Okay.
The rest please think very hard to get the answer, okay?
When he said it sits directly across from the wife, right?
Yeah, like this.
It means like
Like this.
1/6, right? Oh, okay, thank you.
Can directly. So it's not even like diagonal, must be direct. You got the answer? Try your best, okay? Try to confirm your answer, like using some reasoning and so on.
Mr. Lau,
Yep.
is it 4 times 4 times 3 times 3 times 2 times 2?
Oh. Okay,
Is
why?
it 4 factorial times 2?
4 times 4 times 4 times 4 times all these thing is equal to the same as 4 factorial times 4 factorial.
4 times 2 factorial.
Yeah.
Oh.
They are different,
Equals.
They are different,
Wait, it's not the same. Oh, it's not the same. Okay,
They are
wait.
different. Okay.
Yeah.
Is 4 factorial the same as 4 factorial times 2?
No, different. 4 factorial is times 4 factorial is much bigger. Your 4 factorial times 4 times 2 factorial or 4 factorial times 2 factorial? Like that, Bernice?
Or what about 4 factorial square?
Same one. Oh no,
Right.
Bernice one is got no factorial,
I think I'm wrong. I thought it was 4 factorial, 2 factorial.
Oh. How about Kai Xing? Too
You
small.
say 4 factorial times 3 factorial. No?
Huh? 4 factorial times 3 factorial.
3 factorial.
Okay. Then Ming Si?
4 factorial as well.
Huh?
4 factorial divided by 4.
Wow. Okay, so which one is the answer? So they're all different, no? So you all got different minds. Okay, Ming Si, why 4 factorial times divided by 2?
Divided by 4.
Huh? Divided by 4 or 2? Sorry.
4.
Divided by 4. You said. Why divided by 4? Why 4 factorial divided by 4?
Because divided by 4 because you can rotate 4 times.
I don't think so. I don't remember.
4 factorial is because of 4 pairs, right? Is it 4 pairs? 4 couples?
No, it's because wait, I stole in all the men first because
The men.
there's only one way for the women to sit across.
Very good. So there are 4 factorial ways to arrange the men.
Yeah, then I divided by 4 because of the rotational symmetry thing.
Oh, okay. You see, for Ming Si's idea is you first put a man in, right? So where's the man able to sit?
Like that.
Like this? For example here, the man can sit here.
Like 1, 2, 3, 4.
All this? True? No, no. The first man to sit, how many ways can the first man sit?
That's 1, 3, 5, 7.
Oh, okay.
Is it?
Number seat, 1, 3, 5, 7. How come?
I don't know.
Actually, the first person can sit in any of the seats, what?
Oh, yeah.
Yeah, but
Because they are all numbered.
Just...
They are all numbered. They're numbered. They are not.
Right.
Okay, they are not like this. They are distinct seats, no? So the first person can sit anywhere. So you can, yes, the strategy is like the inserting method lah. You try to put in one by one. Let's say you see how it feels. So for example, for husband, you think of the four husband, then they are going to put it in. Then the first one will be how many seats? There'll be 8, right? It's like the box method because now all the seats are distinct. So it's 8. Then after that,
times 7 times 6 times 5.
No, not so fast.
Why?
Because if the person sit here, then next person cannot sit here. Because if not,
8 times 6
they will fight.
times 4 times 2.
Is it okay?
Can.
Can, Then after that, what happened to the wife? only one way to sit. Venice, okay?
Yes.
Then I want to ask, is it because you all didn't see the distinct seats, so all mess up? I don't know. Distinct seats, huh? Yeah. Is it okay? Kai-Xing? Hannah?
So what's the answer?
No?
Huh? Like that only?
Yeah. Once you arrange the
What's the
husband.
wife?
Okay, because the husband has a free row, right? So all these are all the possible seats that the man can sit. Yeah, if they can sit in all these possible seats, sorry, cannot see, if they can sit at all these possible seats, then the wife also have sat at those possible seats. All the possible seats.
You don't need to times 2, right?
No need, because the 8, right? For example, the 8 already accounted for all the swapping, etc.
Oh,
You get it?
okay.
When you have
Thank
8,
you.
yeah, you already accounted for all the different scenarios and so on. Is it okay so far? Yeah. You can ask questions like, what if the seats are not distinct? They are all the same, then how many ways to do it?
How many?
Is it going to be your way?
Yes.
This one, how you explain 4? For example.
Because you can sit at 1, 3, 5, 7.
Is it? Can I sit at number 2 also?
Can.
Okay, see, if all the seats are not distinct, then how to sit them? The rest I think a little bit, then we go to the exercise. Non-distinct. So the first person, let's say the husbands, we see the husbands first, let's say. So the first person to go in will have how many ways?
8.
1. Their seats are not distinct. They are all symmetrical throughout. So the person sit here, there.
Isn't it 2?
Why 1?
Oh, wait,
But they could
1
sit
or
the
2.
other side also.
1 or 2.
They could sit at the other side also. They could also sit at seat 6.
So it's here or here? Is it here or here?
I guess.
That was what I was thinking, but then
2.
I realized that.
Not 1, 2, sorry. 2.
Wow, Mr. Lau.
2 lah, 2. It's either left or right.
Yeah.
Then after that, how about the other person?
Will be either.
What do you mean the other person?
The other
You mean
husband.
like the wife or the next husband?
Husband, next husband.
Oh.
Okay, for example, if the person's husband sit here, right, then the wife will be, so it's gone already.
So, 3? 3 choices?
Why?
Because you can sit at either. Oh no. 6 choices.
Because the symmetry already broken, no more already. They are not symmetrical. The table being arranged with the husband and wife already first pair seated here. They have made the table unequal number. No matter how you arrange, they are unequal number, right?
So it's 2, 6, 4, 2.
2, 6.
4, 2.
4. 2. Yeah.
Maybe it's the first husband. The choices is 2.
Okay, first one again. First one is because all the seats are identical. So when you do the sitting, it's like a person seated like almost like a round table. But then the person can sit here, sit here, sit here, sit here, they are the same. Okay, the person won't be able to tell which seat is he sitting. You get me? Can so these 4 seats will be all the same to the person. Yeah, but it will be different. He will feel different if he sits on the right side or left side of the seat. So there are 2 ways only. Okay, so that's why it's 2 in the first place. Yeah. Okay, for example even if you cannot get this sort of question like totally correct if you are going to do it reasonably in a certain reasonable way, you should be able to get some mark for that. It's not like 100% you will get Q. Okay, so P and C question is not like you either you get 100% or you get 0%. No such thing. It's always that half in between, and you need to know that you try to get as many marks as you can by doing all the reasonable assumption and steps that you do. Okay, then this one coming back to this piece of work this one is considered quite basic lah. I feel quite basic. You should know what to do with all the questions by right. You should know. Okay, actually the worksheet goes to B so I put it such a way that I find this sort of question A and B, these worksheets you should get them because they are quite common. Okay, of course you'll get some uncommon questions as well. Okay, so we look at this one which parts you are not very sure how to do it. For example,
2B.
Question 1 can do.
2B.
Okay, can you do 1B? 2B.
1B.
Oh, 1B is cases.
Yeah, but I don't know how to do the case.
Yeah.
2B is also cases, so
1B
1A is cases.
1A is not cases. 1A is just one step. But I want to 1B.
Right. 1B is cases. I think. Right, Mr. Lau.
Yeah. Okay, 1B. So you want to find how many 5 blocks. What you want? A A you say how many ways, right?
No,
A
B.
is 60. A is 60, but B is like there's 2 cases, is it?
There's 3 cases.
3 cases.
3 cases.
Yeah.
But like, wait.
Because
Why is there
it's
3 cases?
1 brown, 2 purple, and 3 yellow. So if you want to get 5 blocks, you need to get into the different types of color blocks you have. Yeah. So case 1. Case 1. What is case 1?
Brown not chosen.
Yeah.
1 brown, 2 purple. Let's say all these things Yeah. So you have to go into cases and do it. Okay. Can.
Wait, maybe I know why I'm wrong.
Like this. Got 3 cases Yeah. Essentially it's about how many repeated. Okay. 2 pairs. 1 triplet. 2 pair. 1 pair, 1 triplet. Yeah, so it's about how many of these repeated cases. So for case 1, for example, case 1 will be calculated this way. How to calculate case 1?
5 factorial, 2 factorial, 2 factorial.
Can so something like that. Then you go through.
Yeah, I got that. Then case 2 is
This one?
Oh, I think I missed that one.
You missed the case 2.
That one is 5. Yeah.
1 blue, 1 brown, 1 purple, 3 yellow. Okay, means you okay? This one Then what question 2 okay.
2B.
2B okay.
2B, yeah.
What happened to 2B?
I don't know.
Wait,
I got a very big number.
Like I did 4 cases, but it's not enough. Like I have still some mistake. Like it's a bit short of the answer.
There'll be a few cases so I just talk about this case and see whether you get these cases. First case is this. all distinct, right? All distinct. Is it all distinct? Two.
Isn't E 5?
How many?
5E.
Are you sure? Yeah, sure.
Mr. Lau.
What thing? Okay. One more missing. Three. S.
V P.
S.
Oh yeah, yeah.
Okay. 1P. Yeah, like that. All distinct. So it's possible to be all distinct lah. Then case 2 is case 2 will be one pair.
Two string, two or one pair, yeah.
One pair only.
Oh.
Is it two pairs or all distinct?
Well, I think I didn't do two pairs.
Oh. Case 4 one triplet.
I feel it's still not.
Got case 5?
Quadruplet.
All same. Quadruplet, I don't want to say that. Okay. All the same. Yeah, so all distinct. How many ways to do the all distinct? 7 choose 4 times 4 factorial. Or 7p4. Then one pair. How to do the one pair?
Grouping.
2 choose 1. Then after that, 1, 2, 3, 4, 5, 6. 6 remaining letters. You choose 2. Can? You all got do this question, then you will see it coming. Like this. You get it? 2 pairs because one pair.
Why times 4 fact?
Because 4 letter you need to divide by 2 factorial for the repeated pair that you have put into the 4 letter code.
Okay, thank you.
Why do you choose one?
2 choose 1 because you choose either the P pair or the E pair. It's either E or P, so you choose them. Then the 6 choose 2 is actually is more difficult. 6 choose 2 you must be careful. You chosen one pair, then you still have 1, 2, 3, 4, 5, 6 other distinct letters you can choose.
But if you choose from the P, right, Mr. Lau, then don't you have like 5 groups left?
Choose from the P. Choose what?
Choose sorry.
R.
Choose from R.
You still have your P, your V, 1 E, 1 N, 1 C, 1 S. Your E can be chosen.
Oh.
Yeah. So your E can be double up as a distinct letters to choose.
Then if you choose from E like 2 pairs, right? Then shouldn't it be 7 choose 2?
2 pairs, you mean case 3?
No, as in like you take the 1 pair from the E, correct?
If you take 1 pair from the E,
then
you
still got the 2 R left.
No, you only use 1 R.
So there's 1, 2. So there's 7 groups.
6 groups. Still 6. P, R, V, N, C, S.
Oh, because you cannot choose from E again, right?
Yeah, of course. You get it?
Oh, sorry.
Can yeah. Then the next one, 2 pairs will be 2 choose 2. Because you choose the 2 pairs from the R and E. Actually, just one way only lah. And 4 factorial. Oh, too cold. Must go and... Today is quite hot actually. They all turn on aircon one. You see?
Mm.
Mingxi turn on aircon. Kai Xin cannot tell. Then your one you don't know on and off sometimes. Then Bernice cannot tell. Yeah. Okay. Anyway, okay with it. This 2 choose 2 times 4 factorial over 2 factorial 2 factorial. Then for this guy,
Wait, why 2 factorial, 2 factorial?
2 pairs ma. Yeah, R R E.
Oh, right.
And the one triplet is you must choose the E, then you choose one more letter. So one more letter is 6, choose 1. Okay, then 4 factorial divided by 3 factorial because of the triplet. Then here will be only one way. So you plus all together. Okay, it's a very old question, this one. Yeah. Can?
Wait, why 6 choose 1?
There are 6 distinct letters, right?
Groups.
Groups
Oh.
beside the E. 1, 2, 3, 4, 5, 6. Yeah, same as the.
Okay, thank you.
Yeah. Try to get all these questions right, or to a large extent correct, because these are very common questions. Common, but may not be so easy to do also lah. There are cases, so you make sure you get it. Okay. Can move on. Number 3, okay. Number 4.
3B.
3B. Beside Granda, who else got question?
Sorry.
No. Don't say sorry. Just want to know only. Okay. Okay. Mingxi also. Is it Mingxi or you just exercise your hand? Okay.
Oh, I got it wrong.
3B. Why should you put the water bottle in?
Oh, sorry.
Oh.
Never seen.
Okay. The 7 letters college. The middle 3 cards must all be vowels. So you'll find that, I don't know, you just make sure that they are all vowels. So you have O, E, E at the center. So you have D, L, all this one. What else letter? C, L, L, G. Yeah, 1, 2, 3, 4. Yeah, altogether 7 letters. So I want to get this combination. Then here will be 3 factorial over 2 factorial. The middle group of vowels. So they are grouped together that way. Then how about the other 4 letters?
But they say specifically must be in the middle.
Yeah, so it's in the middle. No?
Oh,
you put in the middle that way. Then how about the rest of the letters?
2 factorial. Oh, 4 factorial over 2 factorial.
And that's it. The reason is because
wait, so
yeah, just
you don't have to repeat for the front?
No need, because you can think of this way. I just insert the vowels inside, no matter how they arrange.
Oh, okay.
Yeah, so don't get distracted by because they are at the front or the back. They are not. If you do that, it will be many cases. It will be quite troublesome to do it. Okay, so the answer.
So the number is
times.
Times, right? Okay, thank you.
Yeah, welcome. Okay, Mingxi. Can yeah. So
yeah, 4C.
Quite fun doing all these questions, right? Actually,
Yeah.
I like doing all these questions because the answer is very short. Then you just explore. But I feel it's not fun in exam. Practice okay.
Yeah, because you have to think.
Yeah, but I like this sort of question where you just do the questions. Yeah. Okay.
You need a lot of thinking.
Oh, really? Good.
Yeah.
Y'all want to try all these? There are many questions actually. I didn't print out for you. If you already want to try, wow, many of these worksheets. Yeah. How many ways can this be done if the 5 girls and 5 boys are to form a line with the boys and girls alternate? Okay. Alternate is the key. So you need to have the boy girl like that. This sort of arrangement. Yeah. So in this case, you'll find I can arrange the boys independently from the girls. So the boys are 5 factorial, the girls also. Okay, no matter where they stand, they will have 5 factorial ways on themselves to arrange. Then after that, what to do? If the boys and girls are alternate, then there will be only two ways of alternating. It's either BG or GB. So all the total ways will be times 2. I think.
Okay, thank you.
Can
Then question 5 and 6, like I didn't get the answers for any of them.
Oh, maybe you careless. Yeah. The rest not talking means you all got it, lah.
I need question 6B.
6B.
Only 5B and 6B.
6B. Okay, almost, huh? Okay, so Bernice is the one who got it all. Well done.
I need 6B. I need 6B. Also need 6B. Yeah.
Yeah. So 5A how to do, Bernice?
I don't know if it's correct,
But the answer correct, very high chance is
3
correct.
vowels together. So it's 4 plus 1 bracket factorial over 3 factorial because the L is the same. There are 3 L's. So it's 4 plus 1 because the vowels are grouped together, and there are 4 consonants over 3 factorial. Yeah, then times 3 factorial because the vowels will change within each other. Yeah,
very good.
just 120.
Yeah.
Yeah.
I think it sounds good. Yeah.
Oh, okay.
Then what do you do?
Me?
Yeah, I don't know. That's why you see, it's good to just let me see your work also lah. Then I can see what's wrong instead of just write. I also want to see what's wrong. Yeah, you know.
Okay, I don't even know what I was writing.
Oh, you know, what this P and C thing is, you get it wrong. Yes, maybe you just need a little bit of carefulness in certain part, then you'll get it right. Yeah, but because of that, you maybe just abolish the whole thing. Then you try to learn from other people's solution. Then maybe your solution is not bad. You get me? So it's always good to get from your solution, because if you can come up with the answer, right, that means you have the intuitiveness to get the answer using your own way of looking at it. So maybe your own way of looking at it will last longer in terms of memory, okay, or retention the method. Yeah. So sometimes it's just need a bit of tweaking, you can get it all the time. Then, well, why not? So it's good to share with me your answer. I just look at them. If anything wrong, I may want to ask you why and so on, or I just remark. Okay. So this one is just arrange. Yeah. Okay. 5B. Try to write some explanation when you do the question. Don't just write all the numbers. People won't understand your working. Especially maybe you have some idea, but your idea unfortunately got it wrong. You get me? Yeah, some parts got it wrong. Yeah. 5B, the 3 vowels are separated. So this is a separation slotting method. Therefore, the first thing is we arrange the consonants first. Okay, arrange the consonants first. So this will become 4 factorial over 3 factorial. Then after that, you slot in. Then this is the first step. Second step, you slot in. The number of ways will be 5, choose 3. Then times, because the 3 factorial are separated in this way, so you 5 choose 3. Then times 3 factorial. So after
why times 3 factorial?
Oh.
The 3 vowels.
The vowels are all different. So when you choose, no guarantee that they are still in that all the position taking up. You're just looking at the positions. You haven't looking at how the ordering of the letters. Yeah. So
okay.
Yeah. Okay. So you multiply that way. Then that will do for. Can then number 6 Number 6, you have the 5 married couples, then 10 seats for dance. How many ways can they sit if each couple is to sit together in a row? Yeah, is it done? The 5 I can erase. Yeah, so you want to have the couple in a row, then first of all you have this idea, put them into is to sit together, right? So it's 5 factorial. But each couple has the ability to switch
Two
places.
ways of sitting.
Yeah, so there'll
Yeah.
be 2 power 5.
Cause I thought it's 5 factorial times 2
Only.
factorial.
Oh, because each of
Yeah.
them can independently switch. So there are so many ways.
So the 2 to the power of 5 is for the 5 couples then within themselves.
Yeah, internal switch, correct.
Thank you.
Thanks.
Oh, cause
Okay, sometimes we miss this sort of thing out. Is quite common. Quite common. Yeah, so just be more careful. The 5 lah.
Yeah.
Yeah.
Okay.
It's very common, really. Oh, B.
I'm not sick.
It's okay. We have social distancing.
Yeah.
Okay. I want to ask you, yesterday, all y'all doing what, HBL, right, or SLS? I don't know. Y'all,
Yeah.
HBL.
y'all are what?
HBL.
Is it a live lesson or what?
Yeah.
Recorded.
Oh, your Hwa Chong is a live lesson, so you see your teacher.
Yeah, mine's live. Yeah.
I think it should be the way already lah. Now it's extended, home. Then they, I don't know.
Yeah.
Okay. Then Kai Xing, your one is live or?
Our tutorials are live, then lectures are recorded.
Oh, Ming Xie?
It's live.
I think that's the way to go lah. If not recorded, people will be running out of the house and doing something else. I don't know. Okay.
Oh.
Okay. Yeah. 6B. They want
Yes.
all the men sit in a group to the left of all the women who are seated in the group. No couples can sit together. So this is left is the man. Then wife. Okay. Actually, without restrictions, quite easy to do. But because of the restriction, then you find that this man and wife cannot be together. The husband and wife cannot be together. So that's the only place that you need to be very careful.
Is it complement method?
How?
I don't know.
You can do a variety of methods. You can do complement or you can do direct method. Okay. Yeah, let's look at direct method first. If you want to look at the direct method. Direct. Okay. Who can sit here? 5. 5 people can sit. 5 of the men can sit at the position before the woman.
Oh, then 4.
Correct. So this will be 5. This will be 4. Because the wife cannot sit next to the husband. Okay. Yeah. So in that case, after that, then what to do? Something like that. If you can, try to train yourself to write some short statement to, explain your numbers. Yeah, especially some questions very difficult. You need to explain your idea. If not, your idea may be correct, but because of some mistakes you got it wrong, then it will be like quite pity lah. Okay, your teacher may not understand your method. Okay, so after this, what to do with the what to do? For factorial. Yeah. Is it okay? It's a very pragmatic method to do that. Okay. Yeah, you can check the answer. I don't know.
Yes, correct.
Huh? Is it correct? I don't know.
It's correct. Yeah.
I can't even press my calculator properly now. Okay. I pressed it wrongly. My calculator got the wrong
correct.
answer. Okay, what is the complement method? Shall we do a complement method?
Okay.
It's good to, in exam, it's good to know different methods. Then you can check against your own method. Okay, this one, Kai-Xing, you want to help us? You know how to do the complement?
Yes. Kai-Xing wants to help us.
Oh, I thought Glenda is trying to take her spot.
Is it you don't consider whether it's like husband or wife together?
Correct. So there'll be minus, right? So the husband and wife together. So this will be 5. 5 because in the middle, sorry, the middle pair, right? There are altogether 5 possible couples can be put in the middle.
Mm.
Then after that what? After that what to do?
Find the total.
Yeah. No, something else, right? You cannot just leave the couple here and then happily they are seated there. Then the rest also must sit. Okay, the husband and wife here, but the man and the woman, all the 8 of the rest must also be arranged. How to arrange?
Times 4 factorial times 4 factorial.
Okay, let's say then what's the total? Finish already? This part finish? Then what is the total?
5 factorial plus 4 factorial.
Very good. What's the answer if you do that?
Oh, it's the same.
You get the answer?
Yeah.
Yeah, okay. Well done. And is it okay so far? Bernice okay or not? Bernice look a bit dreamy.
Yes.
Can
I understand.
Can.
Yeah.
So it's a long way to go. As a student, I find P&C, I really need to practice constantly to make my mind sharper. I need to make it sharp. As a teacher, right? For example, last time when I teach, the school always give us like follow up. So only after 2 years, then I come back to the same statistics, P&C. So in that way, I find that after 1 year break, I feel a bit rusty. I can't really figure out some of the questions. Yeah. And so if you want to train for your A level, I would find that you start doing your P&C questions regularly. Like if you can 1 week do a few, at a time, because the answers are quite short. Actually, it's just you need to think a bit. Yeah. So with that, you can take it as a sort of like a break time. When during your break, you try to take a few questions and try. Okay. Then if you don't have enough questions, you tell me lah. Then I just give you some extra. Right. Okay. Then you train in that way. You'll train on your probability. You'll train on your discrete random variable topic and the subsequent topics. Some of these topics they use P&C method to do it. Okay. Yeah. So so I stop here for this tutorial. Okay. You all have all these questions or part C?
Have.
Yeah, you can go and try already. Okay, and part B and so on. Yeah. So I would discuss the next one with you. This one is on probability. You all print out. Glenda, you go and print.
No.
Who print? Kai-Xing got print? No one print. Try not to print. If you can, then don't print. It's okay. You can read from the topic. The source. Okay, this one Wait, all of you went through probability already, right? All of you? Okay, good. So I just quickly go through. I won't go through in depth. Okay, things like this you should know. Experiment, what is that? Outcome, sample space, event. Can you know them? Okay, to know, let me know. Then after that, very cute person throwing a die. Yeah. So methods in probability. There are two broad methods to do probability. Is use a P&C method or the direct probability or using a tree diagram, Venn diagram, and so on. So these two are the broad categories. Okay. Then after that, you know the using Venn diagram, we have what is union, intersection, right, and so on. So do you remember the formula? Mutually exclusive. What to do? What is the mutually exclusive mean? Then the conditional probability, this formula. Sorry, miss out the P. Okay, this one you should know, right? You all know, all of you know the formula very well. Good. Yeah. So and this one you know also. The complement of the conditional is the same as 1 minus the direct conditional. Yeah. Then after that, examples like this, how to shape. Yeah. This few Venn diagram formulas you need to know those A, B, C, D, E. Yeah. So you need to know the formula, how they used. And this part, yeah. Okay. Can you all try example 4 and see whether you can get this answer of A given B? How to find probability of A given B? What method to use and so on. Yeah, got the answer. You got this answer?
No, wait.
Yeah.
No, wait.
Oh,
Oh no.
Brenda, are you sure? Yeah. Oh, yeah.
Oh, it's PA union A intersect B over PB
Yeah.
equals to 4/10 times 2/5.
Yeah, y'all got it. How come cannot get it? Some of you. or haven't worked out yet. So if,
Wait.
4/10 times 2/5
Oh.
yeah,
Okay.
sorry.
No, wrong.
over 0.4 times 2/5 plus 0.6 times 1/3.
Can? I think. Okay, so something like that. Yeah. Questions like that must know how to do. The direct application of conditional probability. Okay, Missy can get or not? After this lesson, there'll be many lessons on all this. I mean, there'll be all these related topics on probability and PNC. Yeah. Okay. Independent events. Events are independent if B occurs does not affect the occurrence of A. So in probability of conditional, we write in this way. PA given B is PA. Then this is the famous formula. This is the original one. But this one becomes popular because it's easy to remember. Yeah. Okay. So when A and B are independent, A and the complement or complement of A and the B and so on, they are all independent of each other. Yeah. Okay. Let's look at an so-called quite a common question. I don't know. Have you all seen questions with intersection, like 3 of them? Have or not? Have? Yeah. In your tutorial. Okay. Let's look at this example 5. Then you see can we do the question? Okay. So A and B are ABC are events, then they have their own probabilities. A and C are mutually exclusive, and they all have all these characteristics. B and C are independent. So find A intercept B probability. Yeah. So what is the method you're going to use? For example, you probably will use the Venn diagram method. That means you'll try to look at how the events are put into Venn diagram. Any formula you can use. Can we use this formula? Can? So you can try what method you have to use to solve the problem. Yeah. What I'm writing is that there are some typical formulas that we can relate to A intercept B. So one is this formula, very popular union formula. Then of course A intercept B also occurs in the conditional formula. So you can see which one to use and so on. Yeah.
How you find P B given A by taking y minus 0.5, right?
equal to?
Wait, it's not 1 minus 0.5, right?
No, they're different. You mean this one?
This one is not right.
No.
How you find P B given A again?
B given A, there's no direct formula except the conditional formula.
Oh, okay.
Only this formula will do. Yeah.
Okay.
Wait. What are y'all doing? I need to know what are y'all doing. Are you doing I don't know. Are you drawing or are you writing down some formulas?
I'm writing down some formula.
Kaixing?
formula.
Writing formula. Okay.
Yeah.
Kaixing?
If I don't know, okay, I try to do by finding probability of A given B times probability of B.
So yeah.
Getting half on the probability of B.
So you're also writing down formula. You're trying to find out some formula. Okay, Mingxie? Okay. This sort of question, when you're like looking at this sort of question, then you find that A, B, C all involved lah. Okay, A, B, C all involved, then and then it's a 4 mark. So probably some work to do here. Then you want to consider like, can I draw the thing out? Maybe I can see something out of that. Yeah, A and C are independent. Mutually exclusive means A, C. Yeah, for example, they are not overlapping at all. Okay, then how about between B and C and so on? Then they never mention much, so this is the most general scenario we can find. Okay, we assume the most general scenario where the B will intersect with A and C, like this. Yeah, so you have this scenario, then you try to find out how do I calculate the respective probability, especially this part. What do I need? Okay, and what do I have? So you try to fill up circles like this. Here's 0.1 because of this part. Then what else?
PA is 0.3.
Yes. If it's 0.3, then what can we say about the how do we write it in? Yeah.
Maybe the what? Oh,
Now what do we do? You can do something like assign x here. Yeah. Then it will become okay. I write outside. Yeah. Okay, so you can do that this sort of thing. Maybe I just right here lah. Some more.
A union B is 0.5.
So what does that mean? So what does that tell us about the center part?
0.5.
This part. So A union B is
0.5.
all this thing, right? So this part will become 0.5 minus 0.1. This part, I want this part only. So it's 0.5 minus 0.3 minus 0.1. Okay, can you see it? Oh, wait. I'm sorry, I'm too fast here. Okay, what I'm saying is how do you find the middle region? No, sorry, I erased. How do you find the middle region? middle region is you take 0.5 for the whole union, right? A union B minus P A minus P B intersect C. Can figure out this one. This whole thing is 0.3. Right? A union B is 0.5. So there's this part 0.1 here. So if I want only the central part, I just take 0.5 minus of these two numbers, I will get the middle. Okay, so I'm doing it here. Where's the working? Oh.
Wait, 0.3 is for whole of A, right?
Yeah, whole of A. Correct.
Then where the 0.5 is for
One more time.
is for A and B, right?
0.5 is A union B.
Which
union
is
B.
the purple plus red part, right?
Okay. Yeah, purple plus all the parts inside. Okay, I draw again one more time. Okay, this is my diagram. A, B, then there's a little part here. So here I have 0.3. Then here is
0.1.
0.1. So you can see I want the middle part, therefore I use 0.5, which is everything 0.5 minus
Wait,
of
0.5 is including the orange part, right?
yeah, including everything here.
Okay.
Right, the whole thing. So I want to get this part is 0.5 minus 0.3 minus 0.1, right?
Minus 0.1.
Can figure out? Okay, understand?
Yeah.
Yeah, so I get 0.1 here also. Yeah, then how do I get A intercept B in this case?
You find X.
I know how to find X. It's a Venn diagram
0.
problem. This part, right? You have one information not completely used. This is this information. So this is your A intercept B.
Oh, I see. Okay.
We are trying to use this information in. So you have X over PB. Your PB is how much?
You don't know. Oh, X plus 0.2.
Yeah. Huh? I feel this sort of question, right? When you see ABC events, most of the time, right, you have to really draw the diagram. You have to draw a diagram.
Okay.
Then along the way, you'll try to use up all the information given to you. So you try your best to use the information. Then you try to solve the problem. Okay? Can you tell me where is this region? The part done. So this part you can solve for X. So where is this region?
The outside.
Where?
Like,
Not in the circle. Yeah. How to find?
After you find.
Yeah.
Oh.
How to find X?
But they give B. Oh. They never give C.
Then what to do? Okay. Quickly I work out the X, what you get? I think 0.2. Okay, X is 0.2. Yeah, how does this help you?
Then you can find what?
What information we haven't used on?
Then you can find PB, which is
Yeah, you found PB. Yeah, very good. PB is 0.4. So what to do after this?
Then you use the PB intersect C.
PB. Can PB times 0.4?
Equals to
Yeah, so because they are independent, right? Yeah, so you can find PC. It's 1/4 lah.
wait. Mr. Lau, actually what does it mean by independent?
They are not affected by each other. Independent means in English it's not affected each other. Yeah, in probability means they must intersect. Yeah, but nothing much you can say about it. There are just no relationship between them. Yeah. Okay. Can so you can find PC, then you can find 1 minus the rest ABC to get the union. To get this part.
Is it if that independent, then it will just be equal to the
No, independent has not much relationship. Independent just that you have this formula to follow. That's the independent part. Okay. So is there any other formula? I don't think so. So that is the only formula we can use. But here we can find PC. If you can find PC 0.25, then this part will be 0.15. And because of that, we can find A union B union C. Right? Then you 1 minus, then you get the answer. Okay, so these are questions for the 3 sets of events. It is getting quite trendy. Okay, ever since A level came out 2 times in the last 6 years. Yeah, something like that. So it became like quite hot in probability problem. I think your school must have covered some of these questions lah. Okay, yeah, can y'all can try these 2 questions as a maybe as a homework lah. Y'all try these 2 questions. These 2. What is that really? Okay, so what happened? Yes, Bernie.
No. I was taking a screenshot.
You take a screenshot like that. Wow, so good. Okay. Okay. These 2 will be the homework. Then can y'all send me the P&C exercise don't send in PDF like Kai-Xing send in PDF is really I cannot do the marking. The PDF doesn't allow me to do the marking. So you'll send.
So I send you
image. Yeah, image. Go to the WhatsApp, then I can just send back to you. Okay. Yeah. Can.
It's very messy.
No, you don't go and tidy up your work. It's okay. Okay. So I just want to take a look at what you are doing. Then in the future, please just write a bit more organized if you find very messy. Okay. Maybe your messy is to me okay lah, not too bad.